Greeting learners. So we have done the part of trigonometry for paper 2. Now we're going to continue now with Euclidean geometry. These are practically the last question of paper 2. And we're going to start with question 8. Question 8.1. In the diagram, as you can see it, O is the center of the circle. Down the question, use the diagram above to prove the theorem which states that the angle subtended by a chord at the center of the circle is equal to twice the angle subtended by the same chord at the circumference. That is proof that, so this is practically the question. They want us to prove that the TOP is equal to 2TKP. This is the angle subtended by chord at the center of the circle is equal to twice the angle subtended by the same chord at the circumference. So we just have to prove that TOP is equal to 2 times TKP. So here I'll need to do some construction in order for us to show that TOP is equal to 2TKP. I'm not going to do the construction here. I'll join O to K. Good. So now, I've done the construction. I'm going to write here construction, draw. This is what I've done actually. Draw, KO, produced. Now, as you can see here, we're having practically two triangles. We have got TKO and KPO. To show that TOP is equal to 2TKP, we're going to start by saying, let's consider here, put some numbers so that it's going to be easy for us to understand. So I'm going to consider this as 1, this side 1, here also is going to be 1, the other side is going to be 2. So what are we saying? That O1, here O1 will be equal to K1 plus T. As you can see, O1, this side is going to be equal to K1 plus T. And every time when you give a statement, you must make sure you give also the reason. So the reason here is a exterior angle of a triangle. O1 will be equal to K1 plus T. But as you can see, that K1 is equal to T. K1 is equal to T. This is a statement, and what is the reason? The reason is angle opposite equal side. Therefore, if we come back here, we're going to replace K1, and we're going to replace T by K1. So we'll be having that O1 will be equal to K1 plus K1. This will give us that O1 will be equal to 2K1. We are not yet there, so we're going to consider this other side of this chord here. This side is going to be O2, and we will do the same. O2 is going to be equal to, O2 will be equal to K2 plus P. O2 is equal to K2 plus P. Practically for the same reason, exterior angle of a triangle. But we can see that K2 is equal to P. K2 is equal to P for the same reason, angle opposite equal side. Therefore, we're going to have, therefore, O2 will be equal to K2 plus K2 because K2 is equal to P. Then O2 will be equal to 2 K2. And then we're going to take the sum of the O1 plus O2. And this is what we're going to get here. O1 plus O2 will be equal to 2K1 plus 2K2. So it will be 2K1 plus 2K2. And O1 plus O2 will be equal to 2K1 plus K2. And you can see practically now that we have come to this O1 plus O2 is going to give us TOP. So therefore, TOP will be equal to 2 times K1 plus K2. K1 plus K2, you can see that is the angle TKP. And then we're getting 2 TKP. Then we are done with question 81. It's simple. So we have expressed that angle at the center is twice the angle at the circumference. This is we started by the construction, and you must make sure that you join K to O so that it's gonna be easy for you to see these two triangles, which gonna help you to get to O1 plus O2. And then we are done with the question 81. We're going to go to the next question, question 82. Okay, so we're going to the next question, and that is going to be 82. I'm going to read the question, and you, in the diagram, this is question 82. In the diagram, O is the center of the circle, and ABCD is a cyclic quadrilateral. OB and OD are drawn. So if O1 is equal to 4x plus 100 degrees and C is equal to x plus 34 degrees, calculate, giving reason, the size of x. As you can see on the diagram, O is the center, ABCD is a cyclic quadrilateral, OB and OD are drawn. OB is a radius, and OD is also a radius. So they have given us that O1 is there. We're going to write this. O1 is equal to 4x plus 100 degrees. So this one we can write that is given. And we also having that C is equal to x plus 34 degrees. So they want us to calculate with reason the size of x, as you can see here. So I'm also going to write that C is equal to x plus 34 degrees. This is what we know. So they want us to get the value of x. Checking on the graph, what are we having? O1 is equal to 4x plus 100 degrees. This is given. Therefore, we're going to have that angle A. This, you watch on the graph, A is going to be half of O1 because O is at the center. So angle at the center is equal to twice angle at the circumference. So that's why we're going to have A is going to be half of this. So it will be 2x plus 50 degrees. And the reason is that what I was saying, angle at the center is equal to twice angle at the circumference. This is the reason. Now, we're going to take the sum of these two angles. We'll be having that x plus 34 degrees plus 2x plus 50 degrees is equal to 108. This is a statement. Why are we writing this? The reason is opposite angle of a cyclic quadrilateral are supplementary. Opposite angle of a cyclic quadrilateral are supplementary. It means x plus 34 degrees plus 2x plus 50 degrees is going to be equal to 108. If you watch it very well on your diagram, so angle A plus C, their opposite angle, their sum will give us 180. So now we're going to solve for x. Once we're having this equation, x plus 2x is going to give us 3x. 34 plus 50, we're getting 84 degrees is equal to 180, and 3x will be equal to 180 minus 84. Let's use a calculator. 180 minus 84, we're getting 96. So it's going to be 96 degrees, and x will be 96 divided by 3, then we're getting 32. So the value of x is 32 degrees. So if you have understood very well this part of Euclidean geometry you have seen in grade 11, these questions are really simple. So we have applied this, that angle at the center is equal to twice angle at the circumference. That's the reason why I've written x plus 34 plus 2x plus 50 is equal to 180 degrees. And after solving, the value of x is 32 degrees. So we're done with question 8.2. We're going to go to the next question, is 8.3. Let's check on our paper. Okay, we're taking the next question. Now it's going to be 8.3. Yes, we're done with question 8.2. 8.3, if we watch our graph, the diagram, in the diagram, O is the center of the larger circle. OB is a diameter of the smaller circle. Chord AB of the larger circle intersect the smaller circle at M and B, as you can see it on the diagram. Now, the first question is 8.3.1. Write down the size of OMB. OMB. Provide a reason. That is the first question, 8.3.1. So if we watch very well your diagram, you will see that OB is a radius, and Being the radius of the larger circle, OB is the diameter of the smaller circle. So we can see that according to Euclidean geometry, we have learned that angle at the on a diameter is always equal to 90 degrees. We can also say angle in a semicircle. So if we watch this OB is the diameter of the smaller circle. So we will say that OMB, angle OMB will be equal to 90 degrees. This is a statement. The reason will be angle on a diameter. Or you can also say angle in a semicircle is always equal to 90 degrees. You can see OMB is a right angle triangle. From there, we're going to go to the next question, and that is going to be 832. Question 832, they say if AB is equal to the square root of 300 unit and OM is equal to 5 unit. Giving reason, calculate the length of OB. The length of OB. OB being the diameter of the smaller circle and being the radius of the larger circle. So we're having AB is equal to the square root of 300 and OM, the perpendicular distance, is 5 units. So in order for us to get the length of OB, we're going to think about Pythagoras. So let's start by saying AB is equal to square root of 300. 300 is 100 times 3. So we'll get 10 square root of 3. Therefore, MB will be equal to AB divided by 2, then we get MB. So divide by 2, here we're going to get 5 square root of 3. Line from the center perpendicular to the chord. Line from center perpendicular to the chord. Yeah, that is OM. So OM is given as 5 units and MB is equal to 5 square root of 3. We're going to apply Pythagoras here. We'll be having that the square on the hypotenuse is equal to the sum of the square of these two other sides of the right angle. And then we'll be writing that OB squared is going to be equal to OM squared plus MB squared. We're having OMB being a right angle triangle. So this is the Pythagoras theorem. That's the reason we're going to write here Pythagoras. And then we're going to replace the values. OB squared will be equal to OM, it was given, 5 squared, and MB is 5 square root of 3 squared. We're going to get 25 plus 25 times 3, we're getting 75, and this is going to be 100. And therefore, OB will be square root of 100 is 10 units. Then we are done with question 8.3. Pythagoras theorem, very important. The square on the hypotenuse is equal to the sum of the square of these two other sides of the right angle. This is what we have applied. And the rest is simple calculation. So we're done with question 8. We'll be moving to the next question. That is going to be question 9. Okay, so we're now taking question 9. And I'm going to read the question. In the diagram, ABCD is a parallelogram with ABC equal to 14 units. AD is produced to E such that AD and DE, they are in the proportion of 4:3. EB intersect DC in F, and EB will be equal to 21 units. So as we are watching the diagram, these are the questions. The first question is 9.1. Question 9.1, they're saying, calculate with reason the length of FB. They want us to get the length of AB. If we watch very well our diagram, here you can think about the proportionality theorem. We know that AB, I'm going to write this value which are given, AB with AB. AB is equal to 14 units. AD is produced to E such that AD to DE is in the proportion of 4:3. EB intersect DC in F, and EB is equal to 21 units. The question now is to calculate with reason the length of AB. So if we consider this proportionality theorem, we're going to say that if we observe very well our diagram, that the FB over EB, FB over EB is going to be equal to DA over EA. And this is a proportionality theorem. As you can see, DC is parallel to AB. You can also write here that DC is parallel to AB. This is the reason for this statement. Now, we're just going to use the ratios. We want to get FB. FB will be equal to DA over EA and multiply by EB. So we'll be having that AD to DE is 4:3. So we'll be having that 4, as we're talking about proportion, and EB was given is 21. EA is in the ratio of 4:3. We're going to have 3. P by P is going to give us 1. So 4 times 21 divided by 3. Let's use a calculator. 4 times 21 divided by 3. 4 times 21 is equal. Divided by 3. We're getting... Oh, sorry. Here, I think I'm having a mistake. We need to correct. EA, if we watch very well, because we're having that AD to DE is in the ratio of 4:3. So EA is going to be 4 plus 3 is going to be 7, not 3 down here. Here we are having 7. So 21 divided by 7, we get 3 times 4, and then FB will be equal to curve unit. This is the value of FB. This is the main reason, proportionality theorem. DC, we can see, is parallel to AB. So this is the first question for 3 marks. I'm going to clean the board and then we will take the next question that is going to be 9-2. We clean the board. Okay, so we're taking the next question is going to be 9-2. 9-2, they say, prove with reasons that the triangle EDF is similar to triangle EAB. This is what they want us to prove with reason. The triangle EDF is similar to triangle EAB. As we can see, we can start already trying to prove with reason. If we consider these two triangles, triangle EDF and the triangle EAB, as they are given, we can see that angle E is common. So we're going to write here that E is common. We can see it on the diagram. Then angle EDF. Angle EDF is equal to angle A. Angle EDF is equal to angle A. Why are we saying this? The reason is a corresponding angle are equal. And straightforward, we're going to say that EA is parallel to CB. As you can watch our diagram. Because these two, EA is parallel to BC, then we're talking about corresponding angle. Corresponding angle are going to be equal. That's why we are having that EDF is equal to angle A. And then if we consider EFD, angle EFD, this is going to be equal to angle EBA. EBA. Angle EFD is equal to EBA. For the same reason, corresponding angle are equal, and because DC is parallel to AB. DC is parallel to AB. So we're having 3 angles. E being common, angle EDF being equal to angle A, and angle EFD being equal to EBA, all dealing with corresponding angle. And every time when you give your reason corresponding angle, you mustn't forget to write the 2 lines which are parallel. Here is EA parallel to CB, we can see it on the diagram, and DC is parallel to AB. And with this we are done. We're going to say that triangle EDF is similar to triangle EAB. This is being a statement. We're going to write that in the case of triangle, angle E, angle A, and angle EBA. And we have done the proof of question 9.2. These are the reasons. Now we're going to take the last question. That is going to be 9.3. Let me clean the board for some space.